Greetings. My name is Yuri Hammond, and today I'm presenting you the paper on topic of development of an embedded operating system based on the Linux kernel for SoC FPGA. The main purpose and task of this paper is to compare the already existing approaches to building an embedded OS and choose one which allow us to build the distributive which will be specifically tailored to be easy customizable, maintainable, which can be ported from one platform to other, and which will support us in development project in all the steps of it. Basically, we need to make possible to support a wider range of hardware applications while keeping our software part mainly standard for all of them. As for outline, today we will talk about different approaches, how they impact on the efficiency of the resulting distributive. Uh, we will talk about chosen approach, which is custom build. We will talk about process of building an embedded operation system. We'll talk about how can we affect and modify the user space system and basically make it work with FPGA pack. And then we will move to conclusions. Talking about building embedded system, at here we were starting with build route, which is basically way to go for small to medium projects. It has a pretty decent preset of built-in tools. It has standard infrastructure. It provide with enough of pre-built and supportive make scenarios. It has specific tools for patching and so on. But in general, build root is not so supportive of highly custom system because most of the configuration is stale or pre-built, and it works pretty clunky with projects that should be updated in fast pace or which will be modified on the fly. So after that, we moved to looking into Yocto, which is the basically whole framework based on open embedded tools, which provides us with amazing amount of pre-built tools, gives us option to customize the resulting system, but alas, it's still pretty strict with modifying and updating the kernel. It still has one big pipeline of building operation system, which basically hits our idea of updating only some parts of the resulting distributive without need to rebuild it all. And generally, it now focused on the large project with a lot of maintainers. But I believe that's why it's widely used in corporate. And for our case, we will need much more options for customize the project. We will need to, even some cases, we will need to change the whole uh, pipeline of building, the resulting distributive, and Yocto does not support it. But full custom approach supports basically everything because it does not have a great amount of pre-built scenarios, and it expects from the engineers to build everything from scratch and then pipeline it, automated by only their needs. And as a result of that approach, we can customize basically every part of resulting distributive. We can modify kernel variables, we can modify the ROM loader, we can modify even the basically standard memory paths. So if we will compare those three approaches in basically specific fields, which is crucial to building the agile distributive, we will see that Yocto and Buildroot is similar, but Yocto looks like basically older brother. When Buildroot provides us with something, Yocto has it and something more, which alas, as for our case, works like negative because while Yocto has established pipelines, has established scenarios, Buildroot can provide us with it and has basically integrated pipelines. They are mostly strict, and for any deep customization of system, you will need to customize the infrastructure before it. Like those approaches are great for established products for corporate, while custom allows us to build specific uh, distributive, use specific tools, modified it as we basically need it in any given point of time. It does not have any redundant tooling. It only those things that you will use and nothing more. While Yocto and Buildroot can provide whole toolkits for doing basically things that are most commonly done. Like for example, Yocto has a whole basis of modifying the resulting user space, while be it suffering with allowing the resulting system to work with external providers on the fly. And in my opinion, one of the greatest positive points of the custom approach is its ability to be migrated or automate the build process in any way that you need. If you want to go big, you can move it to Yocto. If you know that your scenario became more stale, you can automate it and just reuse it in any given point of time while still preserving the ability to modify it when needed. While nor Yocto nor Buildroot can allow the user to modify the whole build process in some specific point of time without going through other steps and updating them accordingly. So custom approach is great for rapid development and development of the specific custom system. It provides us with fine-grained control of the resulting distributive. It allows us to build, tailor, and modify the specific packages for it. It's amazingly flexible because we can modify, update, change any given part of the operation system. It the whole toolkit has minimal overhead. It does not have pre-built tooling, it does not have standard infrastructure, and so on. We can tailor the performance requirement. We can basically, using the custom approach, just restrict use of memory. We can make distributive more minimalistic in any given point of time that we are working with it, and then just update one specific part of it. Like for example, we need to make it much more smaller. We are modifying the user space. It provides great benefit of security because every part is controlled by developers, and we can patch it. We can basically include specific patches. We can, to be honest, even cut off some specific part of the standard system which are not needed but can be vulnerable. And it's easy to integrate with any given custom software because basically we can work with it like a whole Lego platform, to be exemplar. While building it, we divided it into 4 steps. We have ROM bootloader. It's a primary thing that reads starting memory and uh, runs the whole boot process. We have secondary loader and U-boot, which are customizable and can be updated without, for example, updating the kernel, and vice versa for Linux kernel, which is most widely used for embedded development. And last but not least is user space application part, which can be updated, changed, and modified without changing the previous steps. For example, we can migrate from standard Debian user space to Arch user space and vice versa. Or if it's needed, we can migrate to specifically tailor-made one. Also, it allows us to add a specific partition, which can be then fetched by ROM code loader and use it to update the FPGA part, for example, by having the standard configuration for it. We can load it and then mm, reconfigure the FPGA part by using the same, for example, memory piping, even before the whole system is starting, just to, like, for example, have a point of recovery or even provide with updates without the changing the whole system at all. Just pipe new configuration and when system will be rebooted, it will update the SoC FPGA part. The whole resulting operation system is flexible because it's basically one big plugin which consists of plugins. We can replace file system, we can change, modify, update uh, anything with kernel, we can reconfigure U-boot, we can provide new variables, we can set something to be done at the startup even before the kernel is loaded. We can work with FPGA from a user space system. We can update the FPGA even before kernel is loaded if it's needed. And we can basically change the whole platform because we are using the abstracted connections. For us, SoC FPGA is just added hardware which can be changed, and for that we will need just to update only one part of the whole operation system in kernel to specify what exactly main configuration do we have. We can, for example, migrate from D10 Nano to Cyclone 5 and vice versa, which makes prototyping development much easier. The whole system that we have got is highly oriented to rapid development and rapid changes. When we will we are forced to adapt to changing environment, we are expected to be able to update the system in place or even to make system work with functionalities that was not expected before. For that, we will need basically just to update specific part of the system, and then we can run it safely. For conclusion, using the custom Linux build approach, we will have a highly customizable and agile system, which can be migrated if it's needed to any other platform or framework. For example, if we will have stale operation system which will be updated only minimal, we can go and just start building it using Yocto or build root if needed. But before that, we will have great scalability, option to integrate it with any other external sources. We can just port it from one hardware to another. We can provide it with hard updates for FPGA or for operation system parts. It's easy to prototype. We can modify it in any moment, even when we are working in it. Basically, we can update the whole operation system from inside. It's easier for maintain while we developing it because we will not be forced to rebuild the whole distro by some specific pipelines. It does not have any specific tools or pre-built toolkits which can be overhead, and it we can basically create, modify, update, and distribute default packages, which can be updated on its own, and then develop it even on the same platform. Basically, resulting distributive will provide us with option to build the product on a provided hardware and adapt and modify it for any given reasons, while basically perceiving the ability to go big if needed. Thank you for your attention.